Ever wonder how AI can stay reliable when the real world throws curveballs? Like what if a self-driving car sees a stop sign that's been slightly altered? Or a medical AI misdiagnoses something because the scan was tweaked? Today, we're diving into a breakthrough that's making machine learning models rock solid, even when faced with sneaky tricks or messy data. It's called RCP1, and it's changing the game by needing just one sample to work. Let's start with the basics. Imagine you train an AI to recognize cats in photos. But what if someone adds a tiny bit of noise, like a few pixelated dots, to the image? The AI might suddenly think it's a dog. That's an adversarial attack, and it's a big deal. Traditional AI models can be super confident in their answers, but that confidence isn't always reliable. Enter Conformal Prediction, CP, a statistical safety net. Instead of saying, this is a cat, CP gives you a set of possibilities, cat, dog, or bird, with a guaranteed 95% chance of being right. It's like getting a weather forecast that says, there's a 95% chance it'll rain, or maybe snow, or maybe just be cloudy. But here's the problem. CP breaks down if the input is even a little messed with. Think of it like a GPS that works great, until someone jiggles your phone. Adversarial attacks or random noise can make predictions unreliable. That's where robust conformal prediction RCP steps in. It's CP's tougher sibling, designed to handle worst-case scenarios, like a GPS that still works even if your phone is shaking. The catch: traditional RCP methods are computationally heavy. They require running the model hundreds of times per prediction to account for noise. It's like checking the weather 100 times a day to be sure, slow and inefficient. Enter RCP1. This new approach is a game changer. Instead of hundreds of checks, it uses just one randomly perturbed input. How? By focusing on the process of conformal prediction itself, not individual scores. Think of it as testing the strength of a safety net by stretching it once, rather than pulling it apart 100 times. Here's the magic. RCP1 uses a binary certificate, a simple yes-no check to validate predictions. This eliminates the need for complex statistical estimates, which are time-consuming. The result? Smaller prediction sets, so fewer maybe options and faster computations. It's like getting a 95% accurate forecast without waiting for a weather report. What's even cooler? RCP1 works with any model, whether it's classifying images, predicting stock prices, or segmenting objects in a photo. It's also compatible with different types of noise, from random glitches to targeted attacks. And because it's so efficient, it can handle larger models that other methods can't. In experiments, RCP1 outperformed state-of-the-art methods. For example, while others needed 7,110 samples per prediction, RCP1 did the same job with just one. And the prediction sets were smaller, meaning less uncertainty. So why does this matter? Imagine a doctor using an AI to read X-rays. If the model's prediction set is too big, it might list 10 possible diagnoses, making it hard to act. But with RCP1, the set is smaller and more precise, giving doctors clearer guidance. Same goes for self-driving cars. They need to be super sure about their decisions when milliseconds count. The best part? RCP1 doesn't need to know how the AI works inside, no peeking at the code. That means it's universal, whether you're dealing with image classifiers, language models, or even future AI systems we haven't invented yet. So what's the takeaway? Smaller, smarter prediction sets aren't just a math trick, they're a game changer. They let us deploy AI in high-stakes situations with confidence, knowing the model's not just guessing, it's proven to be right. Next time you interact with AI, remember, behind the scenes, tools like RCP1 are working hard to make sure it's not just fast, but faithful. Stay curious, and we'll dive deeper into the math behind it all next time.